All right. Hello, wonderful people. Let's get started. So what we're doing today is we are going to graph quadratic equations to determine the solutions of the quadratic equation. And we are also going to review types of factoring. So there are different kinds of factoring. Now it's called review because ideally you should have done factoring while you were in Algebra 1, but I know it's been a while, especially with all the crazy stuff going on. It may as well just be a whole new lesson, but we'll try to get through this. So solutions to a quadratic equation. So the solutions to a quadratic equation are the points at which the function intersects the x-axis. So in other words, where does it cross this axis here? So you may have different kinds of solutions like we have here. We have two solutions because it crosses here and here. Or it may have one solution when it crosses once. But we call that an intercept because it's where they kind of touch. They don't have to cross each other. They can just touch and that will be pretty much the end of it. There's also a third option of no real solutions. Now this is a complicated one, but I think it'll make sense later on down the road. But again, let's keep in mind for now that the solutions are the number of times it crosses the x-axis. So let's go ahead and graph. Now I'm going to kind of take a little bit of a shortcut on some of these graphing because one, we've already covered graphing, and two, this is a fairly long lesson. So I'm going to try to make this, I'm going to try to keep it in my normal time window that I normally use. So let's go ahead and find the axis of symmetry using our axis of symmetry formula. So we want to make sure that our equation is in standard form, right? So ax squared plus bx plus c, or in descending powers. So 2 power, 1 power, 0 power. So let's go ahead and put it into our formula. So negative b, so remember we got to plug in the opposite of b, so that would be negative 2. And let's see, negative 2 over 2. Negative 1. So I know that my axis of symmetry is going to be here at negative 1, but I need to know where the vertex is. So axis of symmetry means I know it's going to be the same on both sides, but I need to know where the graph begins, where I can begin drawing the graph. So to do that, we're going to plug in negative 1 into our original equation. So I'm going to just write the original equation, but remove x and replace it with negative 1. So now I'm going to square negative 1, which negative 1 times negative 1 is positive 1. And for this term, actually, I'm going to get negative because 2 times negative 1 is negative 2, and negative 3, or 1 minus 5, because I'm going to put my two negatives together. And that's just the way I like to do things. I like to put the same terms together. So if they're both negative, I put them together. If they're both positive, I put them together. And I get 1 minus 5, which is negative 4. So that means my graph is going to begin its vertex right there. To follow the vertex, we're going to use our rule of odds. Now, remember, the rule of odds only works when we do not have a number in front of the highest power, or the x squared, what we call our a value. So if your a value is 1 or negative 1, then you can use the rule of odds, but you got to make sure you know which way it's facing, which in this case it's positive, so our parabola is opening upwards. So going to the right, 1 up, 3 up, 5 up. So again, 1, 3, 5, and back the other way, 1, 3, 5. Now I'm doing this mainly in the interest of time, but if you want to, you can also, you can do the table. All right, if you feel comfortable using a table, I would recommend you stick with that and make a table. So once you know your axis of symmetry, pick a few numbers going to the left and a few numbers going to the right on the number line, and then plug each one of those into the original equation. But if we did that, we would still get the same thing here. So I think a lot of students kind of liked the rule of odds, but again, you can't use it on all of them. So let's go ahead and get our solutions now. The solutions are right here and right here, those two numbers. And luckily for us, it crosses perfectly right there. So I'm just going to go ahead and put the numbers here. So negative, okay, so the coordinate point right here is negative 3, 0. So that's my first solution, negative 3, 0. And I'm going to put an and here because we have a second solution here at positive 1, 0. And these are the two solutions. That's where the line crosses the x-axis. Now again, the graphing is not as important with these, all right? So it's not like super important to where we have to get the graph perfectly, but your graph does need to be well constructed enough that you can tell where the line is going to cross the x-axis. Because if your line, your parabola is all crooked, you know, all degiss, you're probably not going to be able to tell where it's crossing just by looking at it. So that's kind of another way the rule of odds gets works out pretty well. So here I have my axis of symmetry at negative 5. So there we go. Now we got to find the vertex, and the vertex has to be on the it has to be on the axis of symmetry, right? Because that's what it means. It means it's the same on both sides. All right, I got some people getting their kicks off of me saying that. And if you just so happen to stumble upon here and you don't know what degiss means, it means dumb. Or crooked, or something's wrong with it maybe. All right, so let's go ahead and get this part here. Negative 5, square that, you get 25, but this negative is not affected by it because it's outside, so it's actually going to become negative 25. Negative times negative is positive. 10 times 5 is 50, minus 25. So in this case here, I would actually end up with 0, because if I put my two negative numbers together, it'd be negative 50, and 50 minus 50 would be 0. So I know my vertex is negative 5, 0, which is right there. Now, just to make my parabola look pretty nice, make it look like a parabola, we already know there is only one solution in this case, but I'm going to follow my rules of odds. So 1, and then from there, 3, and then from there, 5. Back the other way, 1, 3, 5. And I'm going to try my best to connect these dots. Now, sometimes I have to go a little bit over, so sometimes you notice that it goes a little bit higher if I'm trying to get through certain spots or something. Sometimes it just doesn't quite work out the way I want it to. Okay. I'm trying to get through as many of those as I can. Now, when you're graphing these, try to keep everything on the graph. I'm only doing this because, you know, it's supposed to have a rounded bottom over here, but I'm only doing it because this tool does not allow me to always get exactly where I need to with the parabola. Otherwise, I'd have to draw the parabola with the mouse, and that's a bit of a hassle. So we have only one solution in this case. So the line, if it looked like a real parabola, it'd come down, touch, and then go back up. And I only have one solution at negative 5, 0. So that is the solution for this one. And I'm going to keep things moving along. Let's go ahead and graph this one using our axis of symmetry formula. So I get opposite of negative 6 and 2a, so 2 times a, which in this case it's just 1, 6 over 2, which is 3. And in this case here, that means my axis of symmetry will be on the y value, or sorry, the x value of 3. Yeah. If I tried to draw by hand, draw my parabolas, they would be all degiss. So there you go. I guess that's your word of the day. And let's go ahead and get this one here. So I'm going to go ahead and plug 3 back into my formula here, my equation, 3 squared minus 6 times 3 plus 8. And here I get 3 squared, which is 9, minus 18 plus 8. And if I put my two positive numbers together, 17 minus 18, I get negative 1. So my equation is over 3 down 1, and that's my vertex right there. Now my graph is opening upwards, and it has an a value of 1, or positive 1. So again, that means it's opening upwards at the regular rate. So up 1 over 1, up over 3, up, okay, 1, 3, 5, there we go. 1, 3, 5. So that makes it a little bit easier to hopefully graph. And again, this one looks a little bit off. Sometimes it's just a little bit tough to get these exactly where I need them to. Sometimes I have to go a little bit past just to get the shape right. But sometimes I have to kind of stretch these out a little bit longer so that they go through more of the points. But again, that's just the way I have to do it to make it work. But anyway, hopefully you get the idea. I cannot seem to get it to go through that middle point. I guess I'd have to make it a little bit offset. But it's really hard getting that shape nice and well made. Okay, so now, again, our graph only has to be well enough made, or made well enough to get the x-intercepts here. So in this case here, our x-intercepts are going to be over 2, 0. And it's going to be an ordered pair like this. And the other one, so and over 4, 0. Okay. Now maybe I should just type it out next time. I think that's going to be a little bit easier to read than the other one. Yeah, I might just start doing that. It's a little bit easier to read. And I probably would be a little bit faster as well. But anyway, we're done with this one here. So let's go ahead and move on to the next one. Now with this one here, our parabola is opening downwards because it's a negative. So let's go ahead and plug this in here. And this would be negative 2. Oh wait, hold on. So using our formula, this is opposite of negative 11, so that would make a double negative. 2 times negative 1. Now in this case here, this would be 11 over negative 2, which would actually make our axis of symmetry at negative 5.5. Negative 5.5. So there's 4, 3, 5. And now we would plug this back in to see where the vertex is. And in this case, the vertex is going to be at, and it would take a while. I just use my calculator, and I'm just going to use what I got from my last class and just plug that back in. But the axis of symmetry's y value would be 2.25. Again, I'm trying to keep this lesson nice and short. So that means negative 5.5 up 2.25. Because I think so far I made with the 3 lessons I've had, all of them took like most of the hour, like literally the bell rang during the last one. So I'm going to try to keep it a little bit not so. I'm going to try to keep within the time frame that I'm working with. So if I tried to do the down 1 over 1 rule, it would be like right there, and then down 3 from here. So 1, 2, 3, and then over 1. Now, if I try to graph my parabola like that, it does kind of go through those points. And if I were to do the same thing on the other side, you notice that it kind of looks like it's going through there. And with these, don't forget, you can also use a table as well. But in this case, I'm going to pick only 2 numbers in my table, and that's going to be -4 and probably -7. So if -4 works out, that means it's going to be a solution. So I kind of talked about the solution with the graph, but what does solution mean in numerically? So this is actually what we're going to do. This is going to be like the next lesson after this one is how do we find the solutions of these without the graph? All right, so let's go ahead and evaluate this here. So I get -16 plus 44 minus 28. And if I put my 2 negatives together, so I get 16 and 28, put them together, I get -44. So this is 44 minus 44, which is 0. And that's true because when you're working with these algebraically, you might remember something of setting your equation equal to 0. So if I have -x squared minus 11x minus 28 equals 0, that is true because if I plug in -4, that will be 0, which is why we call this 0. The solution is also called the 0, okay? Because it's where the function, where the numbers equal 0. Now roots, nobody, as far as I know, nobody's used that in years. I don't know of very many teachers that still call these things roots, but I knew when I was in school, that's what we called them. Now, if I also plugged in -7, I would still get the same result. I would get 0 equals 0, which again is a true statement. And anytime we're working with a graph, we're looking for where it's true. Where on the graph is it true? And that is here and here. So there we go, there's that one. Now this one here, be careful because I did say that you've got to make sure they're in standard form, that is descending power. So a lot of times what I'll get is I'll get students that make this the b value, but it is not the b value because if it was the b value, it would have an x. Since there is no x, we treat it as the c value. Now if I were to rewrite this with a b value, I would have to put 0 there. So when I use my formula, I'm going to plug in b as 0. 0 divided by 2 is going to be 0. So it doesn't matter what the bottom number is, it'll always be 0. So my axis of symmetry is going to be right next to the y-axis. Now I'm going to plug in 0, but when I do this, you're going to notice something kind of weird. Now I pointed this out to some of my other classes and we would know what to do here, right? Because I'm going to set it equal to 0. But let's continue this. So I'm going to have x squared minus 9 equals 0. Now I'm going to add 9 to both sides. I'm going to use algebra in this case, just some regular old algebra. Now I want you to think about a number. What number can I square to get 9? Chances are you're thinking 3, because if you square 3, you will get 9. But there is a second option as well, and that is -3. Because -3 times -3 is +9. So in this case, we already know the answer. The answer is -3 and +3. Now, just for the sake of drawing the parabola, let's go ahead and get the vertex. Since my axis of symmetry is on 0, I'm going to plug in 0 for x, and I get -9. So -9 is down here. So my parabola is going to look something like this. Now I could use the rule of odds, but in this case here, I kind of already knew what the answer was, so it would probably be a little bit better to do it that way. But there we go. If I follow the rules of odds, 1, 3, 5, and I would still cross right there. Although my graph would probably be a little bit more over this way, and probably a little bit more up that way. But there we go. And now we can see in ordered pair form, -3, 0, and 3, 0. I said I was going to type them out, but in this case, it worked out pretty okay. Oh no. You know, for this one, I just realized that I did not plug in the solutions as they should be. So I'm going to go ahead and fill those in really quickly. Because again, we're looking at the parts of the graph where it crosses the x-axis. And I'm going to get back to this one, which again is -3, 0, and 3, 0. And I think there's two more of these. Okay, now with this next one, we're also going to be missing another piece. We are missing the c value, which is going to be 0. Okay, so let's go ahead and plug it in. So I have -6/2 times 2, and that would be -6/4. And this would mean that our vertex is at -1.5 or -1.5. All right, and then we plug this -1.5 back into the equation, and that should give us our vertex. Although this one's going to be a bit of a tricky one because I'm going to need a calculator to type in. Okay, so I know it's going to be positive, so 1.5 times 1.5, and that's going to be 2.25 times 2. So that means that this first term is going to be 4.5 plus, and then 6 times 1.5, which is going to be 9. And that means it's going to be 13? No, wait a minute. Okay. Oh, it's supposed to be negative. This is supposed to be a negative. Okay. I knew something looked wrong because that would have been a too high of a number. So in this case here, it looks like it would be -4.5 right here, -4.5. And I could use the rule of odds, or I could use another way of doing this. But I'm going to go ahead and we're going to use Desmos. So if you remember, Desmos is pretty useful for graphing all sorts of things. Just go to the home page, type in DESMOS, and let's go ahead and I'm going to just punch this in here. So 2x, and to get the square, I'm going to push this a square button here. So we get our parabola, and plus 6x. And from here, I can actually just look right at what we got, and we do have our solutions at -3, 0, and 0, 0. And our axis of symmetry, which is correct. We did say it was -1.5 and -4.5. But again, solutions, -3 and 0. All right, there we go. So we graphed it anyway. And again, you can use a table, which I did with my last class, but that did take a while. And we do have a vertical stretch here. So that vertical stretch has pulled our function to make it narrower. And if we wanted to check these, we could just plug in -3 into the original, and if it comes out to be 0, then we know it is a solution. And again, just in the interest of time, I'm also going to do this next one the same way. Although I don't really have to, I can easily just type this in. So -8 times, divided by 2 over -1. This is going to be -8 over -2, and 8 divided by 2 is 4. So I know that there will be an axis of symmetry at 4. Plug that back in, and I shall get, well, in this case, I'm going to save some more time because I just have this graphed already. So we can see the axis of symmetry, and the vertex is at 4, and it starts at -1, but it also opens downwards. Since it opens downwards, it never crosses. It does not cross the x-axis. So what do we call that? I'll tell you what we call it. We call it no real solution. So remember, that was the third option. Either, usually with most parabolas, you'll have 2 solutions, sometimes 1 solution, and in this case, no solution. Now in this case here, I'm just going to go ahead and just draw a basic parabola to show that it does not cross the x-axis. And that looks close enough to what we saw in the on the graph thingy. But again, this one's no real solution because it doesn't cross the x-axis. All right. Now, time for something else, and this one's a bit tougher as well. And I think in the future, I really am considering breaking it into 2 separate lessons. But we got time now, so let's go ahead and do this. So you might have noticed that with some of them, we were able to work out a separate way of working with the problem. Now on this one here, there is another way we could do this. If I were to go with 2x squared plus 6x, there is another way we could solve this without the graph, and I'm going to show you this way really quick. So you might remember factoring, and factoring in this case is to take away something from both numbers. Both numbers are divisible by 2. Both of these terms also have an x. So I'm going to take away an x from both of them. So if I take so this guy has 2x squared, and if I take away the 2x, he had 2 x's, but now one of them's gone, and he only has 1 left. Same thing with here. So it's like distributive property, but backwards. Now, what we're going to do with this is we have 0 product property. So what can I put in for x's to make them 0? So if I divide both sides by 2, I get 0. So that's my first solution. And if I get, so x plus 3x equals 0. And, oh wait, hold on. Oh, my bad. This guy's x is gone. He only had 1 x. So that means he does not have an x here. So x plus 3 equals 0. So what number can I add 3 to get 0? Or we could minus 3 from both sides, and x equals -3, which is what we got right here. So that's one way of solving it. Now, I think it works a little bit better when I show that one to this one to show that they are the same thing, okay? So what we're going to do is it's just like oppositive distributive property. Like Santa Claus gives out presents, but what we are going to do is we're going to take things from people. So we call this greatest common factor because we want to know what is the largest number I can divide 12 and 18 by. So you might say something like 2. And if I did that, I would have 2, and then this would be 6, and this would be 9. 18 divided by 2 would be 9. And 6 and 9 can be divided by 3 as well. So that means that you do not have the greatest common factor. So the greatest common factor in this case is 6. And now I don't like to use the word dividing because we are not dividing. Dividing means that you are splitting something into smaller groups. But in this case, it behaves like dividing, but it's not dividing because we're moving numbers around. So like with 12, 6 times 2 and 18 is 9 times 2. Or actually, hold on, 6 times 3. So what I did was I took a 6. That 6 is gone, this 6 is gone. That's why I'm only left with 2 and 3 left over. So 2k minus 3. And now it's factored. So again, we're not really dividing it. We're what's called removing a factor of. So again, 6 times 2 is 12 and 6 times 3 is 18. And it's just like distributive property, but backwards. And you can even check it by using distributive property. And if you get your original back, then that means you did it right. Okay, so let's go ahead and move on to the next one here. And I have 40 and 64. And usually when I ask what number can both of these be divided by, someone will say 4. So if I divide them both by 4, you notice that I get a different set. I get 10 and 16. They're both even, which means this is not the greatest number I can pull out of both of them. The greatest number I can divide out of both 40 and 64 is 8. Now this one's tricky because we don't have only a number. We can divide them by variables as well. So both terms have an x. So I'm going to take at least one x from both of them. But I want the maximum number I can take out. So earlier I said it's like Santa Claus. So if you're in the group of children, Santa Claus will give presents to groups of children. So he'll give one present to everybody in that group. But if you think about the opposite of Santa Claus, that would be like taxes, all right? You're taking something from everybody, and you want to take as much from everybody as you possibly can. So this guy has 4 x's, so I'm going to take 4 of his x's. And this guy has 8, so the highest number either of them can pay in terms of x is 4. Now they also have a y, so I'm going to take both of their y's. Now let's go ahead and reduce these. So 8 times 5 is 40. So if I take the 8 away, that's only going to leave the 5. There were 8 x's, but now there is only 4 left. This guy, the first guy, had a y, but it's gone now because the outside guy took it. 64, and like I said, I don't like saying divided by because we would say 64 divided by 8, but actually it's 8 times 8 and we took one of the 8s. So that's what it means by reduce by a factor. He had 4 y's, but now they're all gone. They were taken away. He had 1 y, but that's gone too, so he's only left with himself. And there we go. Now that's factored out. All right, so number 3, 14, 35, and 7. Now that's a pretty easy one because they all divide by 7. But the important thing with this one again is how many m's can I take away from everybody? Well, you might be thinking, well, okay, what if I take 3 m's from everybody? So this guy can pay 3 m's. This guy can pay 3 m's, but this last guy cannot. So let's say that, okay, so you're a businessman and you want to make as much money as you can, but you want to be fair to everybody. Let's say that you are in, let's say an earthquake, all right? And everyone's trapped in a building and you have a hot dog stand. Now, ideally, you would give away a hot dog to everybody, but you're a shrewd businessman. So what you could do is ask everybody to pay the same price for the hot dog, but charge by what the poorest person has. Again, that's not a really good design, and that's not a really good analogy. I like the tax man a little bit better because that's the way taxes are. You have to report everything you earn, and the government basically decides what's the highest amount I can charge everybody without people rioting. And that's what they do every single year. But either way, in this case, everybody can pay 2 M's. So let's go ahead and divide everything by 7 and take 2 of their M's. So he had 3 M's, but we took 2 of them, so he's left with 1. And this one's a little bit of a confusing one because a lot of students will put the wrong number here. They'll put 0. Because they're used to this idea, if you take away something that you already had, or you get 0. Now in a way, again, I said it's like dividing. So if I have 7 divided by 7, I don't get 0, I get 1. So the actual answer is 1. And if it was 0, if I were using distributive property, I would not be able to get back to my original problem, right? I can't get this back. So if I times all of these by 7m squared, 1 times, or in this case, -1 times 7m squared is going to be, well, -7m squared. So that one is a little bit of a tricky one because I know a lot of students, again, will put the wrong number there, which it really is 1. Because when you're dividing, the smallest number you can get is 1. All right, let's go ahead and do this last one. Now, 3, 5, and 8 do not have any similar factors, meaning I cannot divide any of those numbers by some number that will divide into all of them, right? 3 cannot divide into 5 because 5 is not divisible by 3. 8 is not divisible by 3 or 5, so we can't take any numbers away. But again, just like taxes, we don't just have to charge people money. We can also charge them on things like property or assets that they own. So that's kind of what we're going to do here. We're going to take their stuff. So each of them has an A. All right, this guy has 2 A's, but they all have at least 1 A. And let's see, this guy has 2 B's, but these guys cannot pay 2 B's. They can only pay 1 B, so we're going to take 1 B from all of them. All right, so let's go ahead and take an A and take away a B. So he had 2 B's, but now he's only got 1 left. We're not taking this guy's number, so he stays 5. He had an A, and we took 1 of them, so he only has 1 left. He had a B, but we took it, so he's got nothing left in the B department. This guy here has an 8, which we didn't take any of his numbers. He has 1 A and 1 B, but we took 1 A and we took 1 B, so he's got no variables left. And there you go. And that's the story of taxes. I mean factoring. Trust me, it gets real when you get older. Hopefully my video has not been demonetized. Okay. All right, so this is another one too. Now, I know for a fact that in Algebra 1, I definitely teach this. I spend about 2 or 3 weeks on this, and I make sure people know it. But I know not all of you are in you're not all in my Algebra 1 class, and I honestly don't know what some of the other teachers here teach. So there's a lot of different ways to do this. I think the most prominent one in recent time is what's called X method, where you make an X like this, you have your A times C and your 2 factors of B and something like that. And it works out. If you know how to do it, go ahead and do it, okay? But my experience is anytime I ask a student, can you show me how to do X method or use this on X method? And most of the time they don't remember because X method, again, does really work well, but it has so many steps to remember. And if you forget 1 step, the whole thing's gone. You can't use it, which is why I stick with my method. And I hate to, promote my own methods, but I call it the Loif method or sometimes the double bubble method. I used to call it double bubble. And the reason I call it that is because your first step is to draw 2 parentheses that kind of look like bubbles. And if you are aware of any other methods, go ahead and use them. Now, the reason I use this method is because I also teach at the college level. And this is one of those lessons that pops up again. And I will have students that actually remember my method over other methods. Now there's a couple of advantages and disadvantages. The advantage to my method is that it is easy to remember. When I was in high school and I was trying to get into college, I remembered my method, or it wasn't my method at the time. I think some other teacher taught it to me, but that's the way I remembered it. And even to this day, I never forgot it because I know how it works. So let's go ahead and try this out. I call it the Loif method because it's backwards of FOIL. And just like going backwards of FOIL, we know how to use FOIL when we have two parentheses. Multiply the first numbers, multiply the outside numbers, then the inside numbers, and then the last numbers. But we're doing this opposite. We're taking FOIL apart. So what we do is we look at the last number, which in this case, my last number is positive 45. So I need to make a short list of numbers that I can multiply to get 45. Now, not only do I need a list of numbers that I can multiply to get 45, but I also need them so that if I add them together, I also get 14. So 1 plus 45 is 46, so that's not going to work. 3 plus 15 is 18, that's not going to work. 5 plus 9 is 14, so that is the one I need. So I'm going to put 5 here, 9 there. Now this is important, this next part here. We look at the sign, we're still on the last number. We look at the sign. Now this positive means they are the same. It means that the signs that go in here are going to be the same sign on both of them. If they are the same, they will be the same as whatever the first one is. So in this case here, they are both positive. And this makes sense because positive 5 times positive 9 is positive 45. 9 plus 5 is 14. And that's the OA part. That's the outside inside is the adding part. So last part is which ones multiply. The inside parts are the ones that add. So if I were to use FOIL method, x times x is x squared. Outside numbers is 9x. Inside numbers is 5x. 9x plus 5x is 14x. And 5 times 9 is 45. So this is factored now. We are done with that one. Let's go ahead and move on to the next one. So again, let's use our Loif method. So I need numbers that multiply to 26. Now you don't have to do this every single time. In fact, usually I don't. But let's go ahead and do the same thing. So I'm looking at the last number. I need numbers that multiply to positive 26. So these are the two combinations of numbers that I can use to multiply to get to 26. But I also need them now. This is the different, this is the OI, the middle part. And that is they need to combine to make negative 15. So if I were to do 2 and 13, which again, if I add them together, 2 plus 13 is positive 15. Positive 15, not negative 15. We need negative 15. So how do we get this? So remember what I told you before. And again, this is a little bit more important than you think. That's because this one is the one that tells me they will be the same. If they are the same, they will be the same as the first one. So this means they are both negative. And this works because if you remember, a negative times a negative is a positive, but a negative combined with another negative is a bigger negative. And you should check them. Always check them really quick to make sure that they will work out. So W times W is W squared. Negative 13W, negative 2W, combine those together, you get negative 15W. Negative 2 times negative 13 is positive 26. So again, be careful. Just because this is positive, sometimes I get people that say, well, you know, they come up with their own rules on how to do this, but those almost never work. So again, this is your most important sign. And the reason I say that is because when I'm grading papers, the one thing that people mostly get wrong, if they get it wrong, they get the numbers right, but it's usually the sign that is wrong. So they, you know, they might put like a negative and a positive here, or a negative negative, or, you know, make these both positive or something like that. That's the part you got to worry about, and you got to check it to make sure it's actually going to work. Now with this one here, I have 48, which actually there are a lot of numbers I can multiply to get 48. There are a lot. 3 times 16, 4 times 12. And I think there's even more than that. Let's see, 6 times, okay. 8. I kind of thought so, but I wanted to make sure. Okay, so I have a lot of different combinations, right? And this one's a little bit even more tricky because it's a negative. The only way you can get a negative by multiplying, because remember, this is the result of multiplication. The only way I can get negative 48 is if one is positive and the other is negative. So this means that the signs are going to be different, so not the same. 6 and 8. Now, here's kind of a hint. Sometimes on these you have to guess, but you want to make the best guess. To make the best guess, pick the numbers that are closest to each other. So 1 and 45, they're really far apart. 2 and 24, closer. 3 and 16, closer. 4 and 12, but 6 and 8 are like right next to each other. So I always pick the 2 factors that are the closest to each other. Now let's see if this works out. C times C is C squared. C times negative 8, so this is negative 8C, plus inside numbers is 6C. Now here we run into a problem because this would give me negative 2C, but we need positive 2C to make the original equation again. Now this is actually a pretty easy fix. If you get the right number in the middle, but not the right sign, it's just an easy matter of changing the sign. And that would make, okay, so C times C is C squared plus 8C minus 6C. So you see all that happened was the sign switched places, and it does work out. That is the correct factorization of that. Now we don't need this bottom part. I'm only doing that to show you that I only did that to show you that it works. Okay, so we checked it. All right, so let's go ahead and start with our double bubble. Now I need 2 numbers that multiply to negative 72. So again, that means one is positive, the other is negative. So I'm going to have to subtract one number from the other. Now if I asked a group of students, what number, what 2 numbers can I multiply to get 72? And without missing a beat, I'm going to get 8 and 9, which again is most people's, like their reaction, their memory takes them right back there immediately. And we test it out. So n times n is n squared. This is negative 8n plus 9n. But in that case, I get 1n, positive 1n, or plus 1n. So again, if that happens, just switch the signs. We got the right number, but it was positive, but we needed a negative. Now there's also another kind of rule that you can use to add in. So if you feel like you're pretty comfortable memorizing more rules, you don't need to memorize this rule, because as long as you keep checking it, you will eventually run into the right answer. But this term here is your bigger number. Now I say bigger, not greater, because positive numbers are always greater. But the one that's bigger, whether it's whether it's a negative or a positive, in this case 9 is the bigger number, so that's why this is going to be negative 9. So that's going to be the right way to do that, and we're pretty much done. Now in this case here, we get a special case for 9 and 10. Now, if I asked you, what two numbers multiply to 36? Chances are, without missing a beat, you're thinking 36. And again, this means they are both the same, and they are both the same as this one here, so that means they are both positive. So A and A. So let's check it really quick. A times A is A squared. A times 6 is 6A, plus 6A is 12A. 6 times 6 is 36. So we are actually done with this one here. That is the number factored. Now there is one more step we could do, but I'll go over that in just a second. Here, start out with our double bubble. And in this case, we only have one possible thing we can multiply to get 1. That is 1 times 1. But again, this means they will be the same, and this means they are both going to be negative, because -1 combined with -1 is -2. And we just put our A value in, and that's why it says where A equals 1, right here, A equals 1. Because this is the easiest thing to, if you have a value of 1 or no number in front of here, this method works really, really well. It's one of the faster methods. Now, I said there was one more thing we could do, and that is to make this into a perfect square trinomial, which we've already kind of worked with. When we were working with vertex form, we already knew how to put numbers in perfect square trinomials. So perfect square means that it's the whole group squared. So I have A, like on number 9, I have A plus 6 times the sum of A and 6. And then the difference of n and 1 times the difference of n and 1 again. So that's why I have 2 of them. So I just put a little square there. Now you might be looking at these and thinking, okay, well, can we double bubble it? But be careful, because if we look up here, it says watch out for greatest common factors. So what we need to do is I'm going to basically factor out a 2 from everything. So take out a 2 on everything. In other words, again, like I said, divide everything by 2, but that's not a really good way of thinking about it, because we're not dividing anything. We're just moving things around. Now we can break it into double bubble, and now we have smaller numbers to work with. And I think you can do this, but it's a lot easier to work with smaller numbers because you have more combinations with bigger numbers. So in this case here, I need 2 numbers to multiply to -20. And if I ask most people, okay, think of 2 numbers you can multiply to get 20, I'm going to get 4 and 5. Now, one of them has to be negative or positive, because, if they're both negative, negative times negative is positive, but we need -20. So in this case here, one of them is going to have to be positive. And we could try this out. But here's the problem. 4 minus 5 is -1. Okay, that's not going to work. 5 minus 4 is 1, but we need 8. So 4 and 5 are actually not the right numbers we needed. So if I made a list like this, the next ones we could probably try are 2 and 10. And if I'm working on the OI part, so the middle part, we got the last number, the multiplication. Now we need to find 2 numbers that add to the middle number, or the outside inside numbers. So 10 minus 2 is positive 8. Now again, we got the right number, but it's the wrong sign. So to fix this, let's switch the sign and test it. K times K is K squared. Negative 10K plus 2K is negative 8K. So we got the inside term to work out. And 2 times negative 10 is negative 20. Now this 2 is necessary. If you left off that 2, you will get this question wrong. So again, we're not dividing, because if we were dividing, that 2 wouldn't be there. All right, so if I divided, like, say, 15 by 5, I don't have to worry about that 5 ever again. So again, we're not really dividing, even though it kind of looks that way. All right, so let's go ahead and do this one here. I'm going to divide everything by 5. So I divided everything by 5, but again, we factored out a 5, really. Now I have much smaller numbers in my trinomial. So x squared minus something z, or actually these are z's. So we can't forget this 5. Now, all morning I've been telling my students, I just sort of left it out, and then I'll be like, is that the right answer? No, wrong. But I didn't do it this time. Okay, now this one's another tricky one, because if I said two numbers that multiply to 6, some people might say 6 and 1. But if you notice our rule of these being the same, right, this plus means that both signs are going to be the same, and they mean that they will both be negative. So in this case, I would get -7, not -5, because we're not minusing one from the other. They're both negative. So that would mean the real numbers we need in here are 2 and 3. And let's check this out really quick. So z times z is z squared. Z times -3 is -3z. Minus 2z is -5z. And -2 times -3 is +6. Whew. So now we know that one's right. And again, you need that 5 there. I was going to try to trick you guys and say, okay, we're done, and be like, no. All right, sort of like horror movies. There's always one last scare. Okay, now these ones are really kind of tough because I hate to say this because a lot of people don't like hearing this. So sometimes you got to try things. Sometimes you got to try multiple things. All right, so like this weekend I was fixing my Xbox. I don't know what was wrong with it, my Xbox One. So my controller wasn't connecting, or when it did connect, none of the buttons worked. So, I tried different things. I tried changing out the batteries. Okay, that didn't work. Okay, I tried cleaning the buttons. Okay, that didn't work. Okay, I tried a different game. Okay, that didn't work. I tried adjusting the settings. Didn't work. And I had to pretty much reset my entire system, and now it works. So anytime something doesn't work, you might have to try several things, which is what we're going to have to do in this case. We are going to have to try multiple things. This is what we call solve by trial, meaning that we try something and it doesn't work, so we try something else. Just like most video games, if you keep losing at a certain point, you realize that that's not going to work out, so you got to go try something else. Now, we use the same rules, right? So 18, I need two numbers that multiply to 18, and I don't know if it's right or wrong, but let's just try 6 and 3. We could also try 1 and 18 or 2 and 9. Now again, this means they will be the same, and they will be the same as whatever the first one is, which my first operation is negative, so that means they are both negative. Now here's where it gets a little bit tricky, because this 2x needs to be factored in there. We need to think about that one too. So let's try it out. 2 times x is 2x squared. Now this is our possible answer. This is not our answer. We're only checking it. -12x minus 6x. And let's see if this works out. -12 and minus 6, that's not going to be -15. So we're going to have to try something else. Easiest thing we could do is switch these numbers and see if it works out. So you're going to have to do a little bit of switching. And like I said, you just got to try something and see if it works. 2x times x is 2x squared, and here I have 12x. Inside number is -3x, and here we go. This is the right combination. -12 and -3 will combine to make -15. And -3 and -6 will combine to make 18, so that will be +18. So this is the correct factored group. Okay, that is that's how it factors out. Whew. So again, sometimes you just got to try something, like fixing something or even getting a job, okay? Because I know some people, when they were younger, they were like, man, I really want this job. I really, really want to, be a blank. And then they finally start working that job and they realize they don't like it. And then they end up having to get something else. Okay. So you just got to keep trying stuff until you're okay with what you got. Now let's go ahead and get negative 48. But in this case here, I already have all the factors for 48 from this last one here. So I'm going to go with 6 and 8. And again, pick the ones that are close to each other. I think those are the most often the ones that work the best. And sometimes they don't work and you got to try a different set of numbers. But just to keep your guesses to a minimum, that's usually what works best. Okay, now they are different here. So that's telling me they are different. So one of them is positive, the other is negative. And at this point, I don't know which one is which. But the A value says that I have to have one of them is 5p and p. So because that's the only number I can, 5 times 1 is the only number I can use that'll make 5. So let's try it out. 5p times p is 5p squared minus 40p plus 6p. So outside, inside, like just like the LOIF, outside, inside is these two numbers here. And this is not going to work. That's not going to work because in this case we would have negative 34 or something like that. So let's try switching the numbers. Let's put 8 here and 6 here, and let's see if we have any better luck. All right, so again, this shouldn't change. So in this case here, we have 5 times negative 6, which is negative 30p, plus 8p. And here we can go with 8 minus 30, which is negative 22. Now in this case, we got basically the right number. Okay, we need positive 22, but we got negative 22. If you got the number, but not the sign, that means you need to switch the signs in here. So all I did was switch them from positive, negative, and that should work out a lot better because, okay, so let's see, 5 times 6 would be positive 30p and negative 8p. So now we have 30 minus 8, which is positive 22. And they do multiply to negative 48. So there we go. And again, I'm only crossing that out because that's not our answer. This is our answer here. I'm just checking it to make sure it works. And I'm showing you how I'm checking it and all that other stuff. So there we go with that one. And this one has a lot of combinations. I forget how many different numbers I could use. There's like 5 different combinations of these numbers, which if this didn't work, I'd have to try something else. So I'd probably try something like, was it 4 and 16 or something like that? Or no, 3 and 16. I'd try all these other different numbers. But in this case here, it looks like it worked out. I think the other one was 4 and 12. So there's about 5 different combinations. And since one is positive and the other is negative, that doubles the amount. So there's 20 possible combinations. And I can also switch where 5 and p goes. So that's like 40 different combinations. But like I said, if you pick numbers close to each other or factors close to each other, you can greatly reduce the number of guesses that you have to take. All right, so let's go ahead and do this one. And there are no numbers I can divide in all of them. So in these cases, I don't have anything I can take out of all of them. So let me think of numbers that I can multiply to get negative 40. So with negative 40, I can make a list of numbers to multiply to get 40. So 1 times 40, 2 times 20, and let's see, I can't multiply 3 to get 40, so I'm going to have to go 4 and 10. And let's see what else is there. Can I do 6? No, I can't do 6. I'd have to do 8. 8 times 5. How the heck did I miss 5? Oh well. Let's just go ahead and go with 8 and 5. And again, they got to multiply to negative 40. If they're both negative, nope, that's going to make it positive. If they're both positive, we're going to get positive 40. So I'm going to just randomly assign one of them to be positive. 3H. And some of these, again, you will have to guess a lot. But sometimes it's just like that. And again, this is not the best way. It's not the fastest way, but it is the way that I think most people will remember for the longest time. All right, let's go ahead and multiply it out. So 3h times 3h, and that would be 3h squared, negative 15h plus 8h. And that does not give us negative 19. So we could switch the numbers. So I'm going to make this one 5 and 8. And let's see if this works out. If this doesn't work, we're going to have to try another set of numbers. So 3 times negative h is negative 24h plus 5h. And in this case, we actually managed to guess the right answer right off, which I was kind of hoping I'd guess a few more times wrong. But sometimes you just get lucky and, you know, you'll get it right the first time or even the second time. So I was trying to, it's kind of random, but I'm also trying to pick numbers that I think won't be it so that we have to keep trying it. But I guess it works out. All right, so with this one here, my last number is 2, or actually negative 2. And I don't know, but I know that since it's negative 2, they need to multiply to negative 2. And the only way to get it is to have one of them be negative. So negative 2 times 1 is negative 2. But now there's a 12 here. And again, I have a couple of different multiples I can use to get 12, or factors. There's 1 times 12, 2 times 6, and 3 and 4. So I'm going to go with 3 and 4 and see if this works out. And again, I don't know if it's going to work out or not, but let's try it out. 3x times 4x is 12x. And the square is going to go there too. So this would be 3x minus 8. So that's not going to work out. So that means we're going to have to try something else. Let's switch these numbers here. So that's 1 and 2. And let's see if this works out any different or any better or whatever. So 3x and 2 is 6x minus 4x. 6 minus 4 is not 5x. So this is not the right combination. So we're going to probably try something else. Well, we could switch here maybe. Switch this and switch this. We'll make this one 3 and this one 4. Now, when you're doing this, you got to make sure that you're not guessing the same combinations, because otherwise that might happen too. You're just going to kind of go back and forth guessing different combinations, same combinations. So you got to kind of have a little bit of process, change one thing each time. So let's go ahead and do this one. So that would be 12x squared plus 8x and 1, or negative 1 times 3 is negative 3x. And this one looks like we got it right. So let's go ahead and looks like we're done with that one. And again, this is not the answer. We don't need that. This is the answer. But we got to make sure we get them right by checking it. Okay, so we got to check it. Checking it's a little bit more important here than it would normally be otherwise. All right, because even when you're doing this, you can kind of get better at this. And sometimes I'll get students that will get the right answer first time, every time, almost. And I ask them, how do you do that? And they're like, I don't know, I just get a feeling for it. And this is one of those things that you can develop a feeling of. You can develop a feeling for it. Or again, there are some strategies you can kind of do to reduce the number of guesses. But I think this is probably one of the best methods in terms of remembering how to do it. All right, last one. I'm going to go ahead and skip this one here for now because it's the same as the last one. And the guess and check or solve by trial does take a while. So this is a special case. So a special case means it's something that happens enough times that you can develop a shortcut for. And it doesn't happen all the time, but there, again, we have a shortcut for it. And this is what we call a difference in squares. Now, difference in squares kind of has a double meaning. Difference can mean subtraction. Like, for instance, your brother has an age difference of 3 years, which means he's either 3 years younger or 3 years older than you. All right, so like difference, you know, like one drink holds 16 and the other holds 20 ounces, so they have a difference of 4 ounces, something like that. But difference can also mean that they are different signs. And it says squares, so this one works with square numbers. 4 is a square number, 2 times 2. 8 is a square number because 9 times 9. 49 is a square number because 9 times 9. 25 and 9, you'll notice they're all square numbers. So this is kind of, again, a shortcut you can use for square numbers. So let's do the same thing. Now be careful with this because I am missing a middle term. It's 0x, right? The middle term is missing. You don't have a regular x. Where did it go? Why would something factored be missing a middle term? Okay, I'll show you. So what we're going to do is in a way, we're going to take the square root of 4, which is 2. Or if I ask somebody what are 2 numbers I can use to multiply to get 4, they'd say 2 and 2. But we know that this is the second operation, right? And like I keep telling you, that means they are going to be different. So plus and minus, x and x. So I use the same things I did earlier, but again, there's that question, where did this middle term go? So if I were to factor it out, or sorry, FOIL it out, x times x is x squared. X times negative 2 is negative 2x. Negative 2x plus 2x is 0x. It canceled out, it's gone. Now because of zero product property and identity property, we don't count this 0x, we just ignore it. Anything times 0 is going to be 0. Or I'm sorry, that was multiplicative rule of 0, or multiplicative of 0 property. And identity property, adding 0 to something doesn't really change it, so we don't need it, we just ignore it. So that's where this thing went, it's gone. There's no middle term, and we are done. And this again is a pretty good shortcut. So y squared is a square number, and 81 is a square number. So plus and minus, 9, 9, y, y. And that's it. Check it. Y times y is y squared. Y times negative 9 is negative 9y. Plus 9y is 0y. So that's why it's not there anymore. It's gone. We ignore it. 9 times negative 9 is negative 81. So this is the right factored form. So again, you're basically just taking the square root of everything in there. So plus, minus, and again, these are all square numbers. 9 is a square number, 25 is a square number, x is squared, y is squared. So 3x, 3x. So 3x times 3x is 9x squared. 5 times 5, y2, y2. Now, in this case, since we have y to the 4, we want to keep them the same. Now, if I had something different, if I had one y to the 1 and a y to the 4 multiplied together, we would get a middle term. That middle term would be something else. So 3, and if I were to multiply this out using FOIL, I would get that middle term to disappear. But again, that's why it's a special case with a shortcut, because you know, there's just a shortcut to it. So I'm going to unsquare these numbers, or again, take the square root. So it was mn with both of them being squared, but now it's just mn. mn plus minus 7, 7. So m times m is m squared, n times n is n squared, and 7 times negative 7 is negative 49. And if I try FOILing it out, I would get negative 7mn plus 7mn. That's a tongue twister, a little bit. but they would cancel out anyway. Now you're probably looking at number 25 and being like, but that one's not a square number. 72 is not a square number. 7 times 9 is how you get it. Now you could do it, I guess, without doing it the other way, but let's, I'm gonna take out the greatest common factor. So I'm gonna divide both of them by 2. There we go. So half of 72 is 36 and half of 2 is 1. So again, if you divide a number like 2 by 2, that'd be 1s squared. Now they are both square numbers. So I'm going to use my square number rule. So what are two numbers that multiply to 36? Well, 6 times 6. Now this one's a little bit of a tricky one, but what two numbers can I multiply to get r to the 6? So that'd be r to the 3. Now remember, when you're multiplying powers or dividing powers, you basically add or subtract them, depending, like multiply is add, divide is subtract. Because powers are already being multiplied, so it makes no sense to put more multiplication in there. Plus, minus, s, also s. And there we go. And again, you need this 2 there. Last one for today. I can take out a 2, so 2 and 32. So I'm going to take out a 2. And let's see what else we can take out. They both have a, but I want to take the most out. So I can take 2 a's from both of them, and they'll both be able to do it. Minus, and then 32 would be 16a2. Oh, wait, I'm sorry. I'm getting ahead of myself. I completely spaced out taking a b. So they both have at least one b, so I'm going to take both of their b away. All right, let's see what's left. A. Looks like, oh no, it's only 1. Everything's gotten taken away. It's just 1. Right, and if I use distributive property, 1 times that is going to give me that, so it's only 1. Okay, now let's go ahead and do this one. So that's be 16. It had 4 a's, but we took 2 of them, and his b is also gone too. So we took the b out, we took 2 of his a's, so that's all he's left with. Now I'm going to go ahead and use my difference in squares. And this one's a bit of a tricky one because a lot of times students will say, oh, that's not a difference in squares because 1 is not a square number. Well, 1 is a square number. It's 1 times 1. And make sure they have different signs. And it looks like we are done with this one. Aha, wrong. Almost got you there. We got to watch out because this part is necessary in our answer. All right, that part is necessary. So now it's entirely done. So I guess I did manage to maybe bamboozle a few people. That's a good comment. That's it for this week. Well, not this week, it's only Monday. But anyway, if there's nothing else, I will see you later. Bye-bye.